So a couple of things. I was looking this morning, and I know that a handful of you have not done the midterm. I'm not hounding you by any means, but understand that that midterm is going to close on Friday, so you have until Friday to get that done. I'm not pressuring you. I just want to make sure that you guys know. I'm not going to try to give you guys a whole lot of stuff this week. What we're really going to be dealing with today is not like an actual like lab stuff, but we're going to be kind of going through some equations. I posted some of these things up in Canvas in the modules on the page, and then I also did the Word document that we're going to look through. So you actually have the questions just kind of written down. We're going to run through these things today and go through these. I also have a new sheet for you, kind of the same sheet that I gave you last week, except that one was like expanded. This one is like a very condensed version, and it has the equations very simplified, very easy. When I go to share my screen, you'll see that in just a second. But it's going to make a lot of easier. We're going to kind of work together to try to plug these numbers in, figure that out. There's some things that we haven't talked about, some things that we're going to kind of deal with today. And then later on in this week, I'll probably post it kind of towards the latter part of the week. I'm going to have a little quiz that I'll have you guys do that's based on these types of things. You can use the equation sheets. I have no problem with that. Again, when we do these equations, I am not worried about you remembering the equations. Okay, remembering the equations is not a big deal. If you were out in the field and you were doing this and you need to use these equations, you can make a little card that goes into your wallet, or you can put it just in your back pocket, whatever. You can laminate it. You can have those things there, so that way you can know how to run these numbers. That's not. I mean, people do that all the time. The more you use the equation, the more you're going to remember. And some of you, depending on what you're going to be doing, you may be using one of these more than the other one. And it just kind of depends on where you're at, what you're doing, and all that kind of stuff. So they are relevant. They are there. You are going to do that if you're in farming in some sort of capacity. You're probably going to do that, whether you're going to be a PCA, whether you're going to be managing things. Spraying applications are there. Their spray applications, for those of you that maybe don't know, if there's anybody that's into like the organic farming and things like that, some people have, like the general public, they have a misconception that, when you're organic, you don't spray anything. And that's just not true. You do actually spray things. You just spray, approved organic chemicals. And so even though you may not be doing, the traditional chemicals, if you're an organic farmer, you're still making spray applications. You're still doing that kind of stuff. It's just the type of chemicals that you're putting on are going to be a little bit different. So a lot of these equations and everything else is still relevant no matter what type of farming operation we have. If you're a PCA, you're kind of going to be working kind of on the back side of this. We focus a little bit more on kind of like the operator side, but some of the equations are going to be relevant, and sometimes PCAs, they help out the farmers, with these applications to make sure that you're applying the right amount of chemical, on the field. So that way they're going to, that way they order the right stuff. They wouldn't want you to order the wrong material. You add too much, and then now you don't have enough to complete your field. So it really kind of, is them. And I've had lots of PCAs that have helped me, when I was spraying out here in the orchard. They would help us quite a bit, with a lot of these things. So it really is kind of relevant, to those. Probably the ones that it's maybe not, as relevant to are the, those of you in here that are AgCom, but we just have to get, the AgCom, you guys are just trying to get a general idea, on how, ag works. You guys have to take a lot of different ag classes, and this is just kind of one of them. So, although you may not be using that very much, it's still kind of cool to know how we do these things. So any questions with the midterm right now before we go and get started, or do you have any issues? Have anybody tried to do that? Maybe you had issues trying to get into it. I know I had issues kind of creating that test, trying to move some stuff over and whatnot, but hopefully it was smooth for those that have taken it. Nothing? All right. So I'm gonna go ahead and I'm gonna share my screen so that way you guys can kind of see, what we've got here. And I've just got like two windows here. You guys have both of these documents on your, in your, the week 10 module on the page. You have both the hard copy and you have, well, not a hard copy, I guess, but you have the electronic version in Word. And these ones should convert over easy. I've had some students that have had trouble converting certain documents over, not necessarily in this class, but these ones is just pretty much words and stuff. So they're in there, they're in your Canvas, they're in that page there. If you look at the page, you can see these questions. Again, I'm not looking for you to actually answer these questions, but I kind of want you guys to follow along and do that. I could have done a recording of this, but sometimes when we deal with math, there's a lot of questions and a lot of different things, or if we go quickly, you may not understand it, and going through it and watching it again may not help you explain it. So please, just like last week, if there's anything that you don't understand, don't feel like, you're not getting it and it's because of you. Okay. We all learn a little bit differently. And some people math comes easy, some people math doesn't come easy. So I'm not going to hound you. I'm not going to razz you. I'm not going to do anything, like that. If you have a question and it seems like it's a dumb question, or even if I have to repeat myself, I have no problem with that, because sometimes that repetition is what's going to help you understand this. My goal is that you go through and we can answer these questions and we can put these things down. And then when you go to take your quiz, you will be able to do that stuff on your own. The quiz is going to be a multiple choice. You're going to type in a numerical answer. And then if it's right, then it's right. But we'll kind of do that, and we may do a couple more, just to kind of refresh you as we go through. We're going to start getting into some other stuff, after this week, but I may just kind of throw in a quiz just to kind of keep it fresh and keep it in your mind every once in a while with these things. But we'll see where we're at, and we'll kind of go from there. So on this left-hand side, if I can click on this, you can see we've got a lot of the different equations. Now I screwed it down and perfect. These equations, right? These are the same ones that we had on your sheet, with the exception that I've added a couple more into here. So when you're doing a test, if you're doing a quiz, or if you're doing like the final, because these questions will be on the final as well. That's why I want to give you guys as much kind of practice with these as possible, so that way we understand it. You can use this sheet right here, this, calibration. I don't even know what the name of this thing is. Something like calibration of sprayer equipment, like short version. It's posted up. It is in the module. It is posted in the module in the page, but then you also have the Word document as well, that you can kind of download. But you are welcome to use these things. Again, I do not want you to be stuck and not have to use these equations at all. But this one's nice because it's short, it's sweet, it's concise. You basically are going to read your question and you're going to find which one of these equations you should plug in. And some of these ones I don't have equations for, because there's not it's not real complicated, but some things that we'll run through to make sure that we understand what we need to do. So we'll go ahead and we'll jump into the first one. And if you get lost at any point, don't hesitate to stop me, and we can kind of go from there. So what GPM nozzles would be needed to apply 18 gallons per acre, right, the GPA, if the speed of the application was 5.5 miles per hour and the boom had 11 nozzles placed at a 20-inch spacing? So right off the bat, okay, we're asking the question, what GPM, or gallons per minute, we're going to be dealing with. So right on this left-hand side, we've got all these equations. We've got to determine which one we are going to use. Obviously, okay, using a lot of common sense, the ones that say GPM, okay, are going to be the ones that we're going to use. On these ones, I told you guys last week that there was kind of not really a trick, but there was either one of these is going to work, and you're typically going to be able to get the answer that you want from either one of these equations. Some of them may be more simplified and easier to do and less steps. Remember, where you're going to screw up on these things is when you have to convert stuff. When you're having to convert, minutes into hours, when you're having to convert ounces into gallons, and understanding those things and understanding those conversions and where you need to convert and what numbers you're dealing with. That's where people mess up. It's not the equation, because you have the equation. You get to use the equation. Okay, so just kind of going through and practicing these things, that's there. But we know we're going to be dealing with GPM, either the GPM total or the GPM per nozzle. And based on what we're asking, okay, it's going to be, one versus the other. Now, if you remember the swath width, okay, we know what miles per hour is. SW and W, right, is either swath width, that's the width of the whole machine, or you have the width, that's the spacing between each of the nozzles. Okay, we have our constants of 495 and 5,940. Those are going to be the same. Again, I'm not going to dive into why those numbers are that way. But just understand that those are constants. Okay. If you care to know and you want to know more in depth, hang out after today and I will explain that to you. But if you don't, which you really don't need to, then we're not going to worry about it. So what we need to find, right, is miles per hour. We need to find gallons per acre. Okay. And then we also need to find either the swath width or the width. We know in this equation that we have our GPA is 18. We know our miles per hour is 5.5. Okay. And so really the biggest one, and this is the one where we kind of determine which of these equations are we going to use. Do we know the swath width or do we know the width? Well, we know that we have 11 nozzles. We know that they're placed 20 inches apart. We could multiply that 20-inch spacing by the 11 nozzles and get our swath width, and then we could use this top equation right here. But in my opinion, and this is how I would do it every single time because it's easier, you're going to get the same answer. But instead of having to multiply 11 by 20 and then adding another number into there, I could simply just take my 20-inch spacing and plug that number in as my width, because that width is your nozzle spacing. I don't have to do any additional math. This question, if we pull this thing up, we'll kind of type these ones in. We're going to use this equation right above us. This one should be pretty simple, right? We know our miles per hour is 5.5. So we're going to type that in. We're going to multiply that by our width, which is 20 inches. Okay, it's important to understand that that width has to be in inches. If it's the swath width, it has to be in feet. So not only would we have to multiply these, we'd have to divide that by 12 to convert it into feet. And again, the conversions are where you're going to screw up. That's why I recommend just using that bottom one, because that's all we really need. We can always get other information out of this stuff. So I'm going to start over since I talked. 5.5 miles an hour times a 20-inch spacing on the nozzles. We're going to multiply the GPA, which is 18. And all of that 1,980 gets divided by our constant, which is 5,940. If we hit enter, that answer right there, okay, is what we're looking for. Now, we're not looking for the total GPM of the boom. We are looking for what GPM nozzles we would need to put in. So when we look at the XR like T-jet nozzles, we have the different color codes, and those things have different orifice sizes, which are going to allow more or less chemicals through. That's exactly what we're looking for. So our answer on this one is 0.33 GPM nozzle, something that's going to be within that range. Obviously, we're going to have to adjust pressures up and down to actually get that, because we may have a nozzle that's a 3.0 or a 0.3. Oh, I typed it wrong. I put my decimal in the wrong spot. You might have something that's a 0.33 or a 0.30, 0.35 at 40 PSI. To get that 0.33, we have to adjust our pressures up and down, maybe a couple PSI. And that's going to adjust to those nozzles there. So it gives you that good selection. We don't want to put a nozzle that's going to output at 40 PSI, 0.4 GPM or 0.5 GPM. You're not going to be able to get that pressure in that system to be able to spray out in that pattern. So when we do these equations and we figure this out, we're like, okay, our nozzles need to spray at 0.33 GPM. Then when you go to put on the nozzles on that spray rig, you find something that is close to that at that rated 40 PSI, and then you adjust them accordingly. If you wanted to know from this, if you wanted to know what our total GPM would be, so our gallons per minute that we are putting out, you would simply just take that 0.33, and you'd multiply it by the number of nozzles. In our case, on this equation, it's 11, okay, and we would be outputting 3.63 gallons per minute from this tank here. So you can get that information. That's not what this thing is asking for. So I'm just giving you more information to try to confuse you. Does that make sense? Is that pretty easy?
Yes.
Yeah. Cool. That was not hard, especially because we can plug those numbers in. As much as you can, do that. If we wanted to do this 495 one, okay, there's more steps, and we do have to do conversions. We can't forget that. It's going to throw our numbers off. I will tell you, I'm not going to give you an equation where you're going to have a nozzle that's going to output 2 gallons per minute. Okay. The nozzles are going to be within a range. It's going to be probably between a 0.2 to maybe up to a 0.6, and that might not even be the range. Most of the time it's going to be within that range. I'm not going to throw numbers at you in these practice examples on your quizzes and on your test that are completely out of what we have been practicing. You may get those in some cases, but because you guys are learning, I'm not trying to mess with you a little bit on that. Cool. So we'll move on to number 2. To check, let me get rid of my equation, my calculator there. To check calibration on a sprayer that was set to spray 0.42 gallons per minute per nozzle at 40 psi, how many ounces should be collected? There should be a B in there. How many ounces should be collected in 15 seconds from each nozzle? Okay. So if you think about last week, we kind of, are doing the same equation, except we're working this one backwards a little bit. Okay. And we want to make sure that we are getting these things and we're getting the accurate information. So if we had a nozzle, okay, and really the 40 psi in this thing, it's kind of irrelevant. In this example, it's just kind of there to kind of throw you off a little bit. Sometimes there are those things there. But really what's important is these nozzles are set to spray 0.42 GPM. We want to check that and make sure that they are actually spraying 0.42 GPM. And if you remember from last week when we do the collection, we're not going to sit there under each nozzle for 1 minute. Okay. If you did that and you're doing this by yourself, and if you take the example of this last equation where we had 11 nozzles, it's going to take you 11 minutes just in collection to check all of these nozzles. Okay. That 15-second interval is going to cut this down to just a few minutes of actually trying to check this to make sure that we're spraying. So we need to convert on these things. And this is not one of the equations on this left-hand side. It doesn't exist, in here. This is just kind of having some knowledge. And if you think about last week, can somebody help me out? How many ounces are in 1 gallon?
$128.
128 ounces in 1 gallon. So what do we do on this equation? We're going to take our 0.42. Actually, I don't need to do that on here. Let me pull out my calculator. So we're going to take our 0.42 gallons per minute. We're going to times that by 128 because we have to convert these gallons, right? GPA is gallons. We have to convert this into ounces, okay? Because we're asking how many ounces should we collect. And that means that we're going to be, outputting in 1 minute, 53.76 ounces, okay? Now that's in 1 minute. This is asking us how much we're going to collect in 15 seconds. What do we need to do to convert this into 15 seconds? Take a guess. If you're wrong, I don't care.
Divide by 4.
Divide by 4. Why divide by 4?
Because there's 4 15-second intervals in 1 minute.
Boom. That's it. So you take that number, you divide that by 4. And in this example, we should collect 13.44 ounces, in a 15-second interval, 15 seconds. Okay. If you do this and your sprayer is like there and you're like, okay, this is what I should be getting, and you do a test on this and you collect something that's, pretty close to 13.44, we don't have to be exact. If it was like 13.42 that you collected, okay, if you have something that can measure that accurately, we're going to say that's pretty good. If you have a nozzle that's collecting 12.44, probably have something that's blocking it. Maybe need to clean the filters off. You're going to have, there's some sort of issue that's there. If you're collecting something that's like 15.44 or 14.44, maybe that nozzle is worn out and maybe you need to replace that. Okay, especially if there's just one standalone one that's not going. That's assuming that your PSI would be at 40 PSI. You could adjust that if all of your nozzles are consistently higher. We could adjust our PSI down and try to get that 13.44, GPM. Okay. If you have one of them that's off, we probably need to replace that or maybe clean the filters out that are kind of behind each individual nozzle. Okay. Not too bad. This is kind of similar to what we did, just kind of working that equation backwards. Okay. But that one, we don't have an equation because it's pretty simple. What would the application rate? Does that make sense? Number 2? I don't want to move on in this.
Yes.
Cool. So number 3, what would the application rate per GPA, gallons per acre, be with the following? When we talk about the term like application rate, we are talking about gallons per acre. Okay, that's why I put that in parentheses there. Okay, so if you see the term the application rate, it's always going to be dealing with gallons per acre. You may not see that GPA. That's just kind of terms that we're going to that people use when we talk about our application rate. Just understand that they're talking about gallons per acre. Okay, so what would the application rate per acre be with the following? We've got nozzles. They are checked. They were flowing at 13.5 ounces per 15 seconds. We're going to drive the tractor at 5 miles per hour. We have 11 nozzles and they're spaced at 20 inches. Again, if we go on this left-hand side here and we kind of check to see what we have, we want to know what our GPA is going to be. Okay, so we're going to be dealing with one of these two equations. Just like the last one, okay, there's the constants of 5,940, 495. Okay, and the two differences are whether we're dealing with the swath width in feet or whether we're dealing with the swath or the width in inches. Okay, so it's inches and it's feet on your swath width and your width. One of the things that we need to kind of look at, right? What are our numbers like? Okay, we want to know what our application rate is going to be. You could do either one of these things. Okay, what we're going to do is I'm going to run through. Again, try to simplify things as much as possible, but at the end, we're going to have to change some things. Okay. So whether we do it at the end or the beginning, I'll run through both equations with you. So that way we can do it on this one and I can show you the differences between them. Tab that over. Okay. So if we have this, we're going to run through this equation here. I'll kind of put this up at the top. We're going to run through our GPA. We're going to do just the width. Okay. So we're not worried about the nozzles right now. We're just worried about the spacing of the nozzles. If we grab our numbers, we have GPM that's here, right? We know we have that thing. We're getting 13.5 ounces per 15 seconds. And then we have our miles per hour, which is 5. We're going to do this one first. We're going to do bottom first. We're going to go 5 times our nozzle spacing, which is 20 inches. It's always going to be a pretty standard at 20 inches too, because that's how the nozzles, the way that those, those nozzles kind of flare out, they almost always have the same spacing. They may change a little bit. I may say 21, 22, 18, but they're going to be within that range there. So on this equation, we got two parts. In the very bottom of this thing, we're going to have 100. So we're going to type in 100 right here at the bottom. Then we'll go back at the top. We know that we want our gallons per minute. We don't know what our gallons per minute is. We know what our ounces in 15 seconds are. So just like we did last week, we're going to have to take that 13.5. We're going to multiply this by 4 because 60 or 15 goes into 64 times. That's going to give us 54 ounces. To convert this into gallons, we need to divide that by the 128. That is how many ounces are in a gallon. And that's going to give us 0.421875. Now, at this rate, because this is like decimal numbers, I could round this stuff up and I could say, okay, it's 0.42 GPM. But for me, I like to keep it as accurate as possible. And so I'm just going to leave this number in my calculator. I'm going to multiply this by that 5,940. And then I'm going to get 2,505.9375. Okay, again, I really want to be at the end of this 2 decimal points, but I'm going to leave this in the calculator. We know, right, 2505. You could type this thing out if you did this in the other order. Okay, but if I type it out here, I know that this is going to be divided by that. And then all I got to do is just equals that. Underline it here. All I got to do is just, what does that stuff equal? So I take this number, divide that by 100. It's all staying in my calculator. And I'm going to get 25.05. Actually, we'll do 0.6 because we'll round up for that. Okay. And that is our gallons per acre. Okay. Pretty simple, pretty easy. If we were to do this again, and we were to do this with the other equation, same kind of thing. The difference is our swath width, we're going to have to take this, our nozzles, we're going to have to take 11 times 20, because that's how many nozzles we have. That's the spacing we have on each one. That's 220 inches in total length. that equation, the swath width is dealing with feet. That would not be the right number to put in. You would get a very different number. So we want to take that number, we're going to divide that by 12. That's how many inches are in a foot. And we're going to get 18.33. We'll do the bottom part of this just like we did right over here. Instead of getting 100, we're going to get something else because we're going to multiply this number by 5 miles per hour. And I'm going to get 91.666667, right? And I could type those out, but that number is going to just stay there. Repeat the same thing on the top. Okay, our GPM for our total boom width. We could do that same equation. We know 13.5 fluid ounces. We times it by 4 because that's how many times 15 goes into 60 seconds. That is how many ounces we have in 1 minute. Divide that by 128. We get 0.42 GPM. That is for one nozzle. Okay, it's important on this one that what we do is we multiply this for our total boom. So you have to multiply that by 11 to get 4.64. Okay. Have I lost anybody yet? We good? That 4.64, I'm going to multiply that by that 495. That's that constant. And I get 2,297.10937, right? Okay. I can divide that number. We'll write this thing out. 2,297.10937.5. I don't want to do that. Underline that. Underline that. Okay, so if we take that number there, we divide that by the 91.666667. We were somewhere around that age or somewhere around that area. We get 25.059, right? Or 0.6. Either one of these ways, right, is going to be correct. We got the same answer no matter which way. Which one of these was easier to work with? The left-hand side or the right-hand side?
The left.
The left. Was there a lot more numbers in this one? It might have been a little bit more confusing. If I had given you the width that this thing is going to spray, it might have made more sense, right? Because then you don't have to do those equations, right? It really depends on what's given to you, okay? I almost tend to, more than any time, I almost tend to run with this equation here and this one, well, I guess really these two, just because those two tend to be a little bit easier. More often than not, those are the answers you're going to get. And then if you want to know, like on this one, if you wanted to know your total GPM, just multiply by the nozzles. It's a lot simpler. We're not having to kind of convert inches into feet and do all that kind of stuff. You may have to do that sometimes, so just be aware of it. Understand how to use both these equations. But in this example, you can do either one. There is more than enough information for you to do that, and it's going to be fine. We don't have to worry about which equation you use, but do whichever one makes more sense to you. Okay, whichever one's simple. Simplify the stuff. Simple is better every single time. Cool. Questions with this?
I have a question.
Yes, ma'am.
So to get this swath width, you just multiplied 11 by 20, right?
Yeah, that's correct.
Then,
So if you,
okay.
Yeah, so if you have like 11 nozzles or if you have 12 nozzles, 13 nozzles, it doesn't matter, right? The area that it's going to spray is the number of nozzles times 20, and then that's what you get. Okay, that's the swath.
Okay. Okay, thank you.
Mm-hmm. All right, number 4. Your PCA recommends a 2% mix of Roundup, which this is very often, you might maybe not necessarily 2%, but you may go more, you may go less. A 2% mix of Roundup for general spray needs. So you're just spraying weeds, maybe around kind of on the roads or whatever. Your sprayer has an 180-gallon tank. How much Roundup are we going to mix into our tank? This is not an equation that we have on this list. So looking at that left-hand side really isn't going to do you much good. But this is just kind of some general kind of common knowledge, that I think you guys probably have. And if not, when we do it, you might think, oh, okay, yeah, I knew how to do this from the beginning. But does anybody know what we would do to figure out if we wanted to apply a 2% mix or 2% ratio of Roundup? What would we do if we filled this tank up all the way with 180 gallons? How much Roundup would we need to put in? Or how would we figure that out? Any ideas?
Would you multiply 0.02 by 180?
0.02 by 180. Why 0.02?
Because that's the decimal form of 2%.
Yep, that's correct, right? If you guys don't know, okay, if you have 2%, we're going to put in 2 right here. And we take that and we want to convert that into percentage. If we divide that by 100, we're going to get 0.02. Whenever you're converting percentages, okay, just understand, move that decimal 2 points. I think this calculator has this, and I'm going to try it right now. So I'm going to try it 2, and I'm going to hit this percent thing. Oh yeah, see, no, that doesn't do that. Some calculators will actually do that conversion for you. I think my iPhone does that, where it will, if I hit the percent button, it'll actually convert that into a percentage. This one does not. So don't, be wary of that. But understand it's 0.02, right? And we're going to multiply that by 180 gallon tank that we have. If it's a 200 gallon tank, multiply it by 200. If it's a 1.5% ratio, go 0.015, and that's going to give you your 1.5. Those numbers are going to change, but how you do it doesn't. So 0.02 times 180, that's going to give you 3.6. What is that 3.6 representing? What's the words that should come after that? Right, that's how much Roundup, but it's our gallons, right, of Roundup that we need to put in there. Okay, so we would need to put 3.6 gallons of Roundup. Now on a word sheet like this, okay, I would make sure that you write out. Notice how I'm writing out. It's ounces. It's GPM, or it's gallons, or whatever it is. I didn't do it on. Well, I did it on this one. I didn't do it over here. It's important to do that. When I give you a quiz, it is going to be a straight number. You don't have to worry about what form or what unit it is measuring. Okay, because we're going to assume that stuff. But if you're doing like a word equation like this, you're writing things down. It's important that you put down gallons, because maybe you have ounces and maybe you need to convert that to gallons, and you don't want to get those confused. So as much as you write it down, it helps kind of finding errors later on. Gallons of Roundup, right? Boom. Simple. It's not too hard, hopefully. All right, where are we at? What is the area covered per minute if you are spraying at 6 miles per hour and your sprayer had a boom width of 24 feet? Now, this one is a little bit more complicated. We haven't really dealt with one of these things, like kind of really dealing with speed and kind of messing with speed. But on the sheet that I gave you last week, you have you had a little equation about miles per hour on the top, okay? And what that equation was, I think I have it on here, maybe. Yeah, so miles per hour, this is like the distance that's kind of covered, which we will use this one today in another example. But in that, we have some, distance in feet times 60 times, how much seconds it takes us to go times 88. Now, when we're going, what's important for you to kind of remember is that when we are driving a tractor, if we are going 1 mile per hour, we are driving 88 feet per second, okay? If you're at 1 mile per hour. If you are driving 2 miles per hour, you are driving double that. So what would that be? If I can do my math, what's 88 times 2? 166? I think I'm wrong on that. 176. Okay, so it's 176 inches or feet per second if you're going 2 miles per hour. That thing just kind of expands and goes forth. Okay, so to do this, and I put an equation in here that's going to make your life a little bit easier. If you're driving 6 miles per hour and you have a 24-foot width, the first thing you need to know is how much ground am I covering per minute if I'm driving 6 miles per hour. So if you look at this thing, we want to look at distance covered here. Okay, and you can see the distance that we're covering. We have our miles per hour times that by 88. That's going to be that constant. That's how much we're moving, how many feet we're moving per second or per minute. No, that's per second. When we are driving these tractors here. So to do this equation and figure out how far you are moving, how many feet we are moving forward, what you need to do is you need to take and plug those numbers in. We have 6 miles per hour. Okay. We're going to times that by our 88. That's going to be a constant. It's always there. Okay. It's important that we do that first. And then we divide that by the amount of minutes. I did not put the division in there, did I? Here, let's do that. I'll repost this thing with that division in there. We divide that by the number of minutes that we're doing. In this case, it's asking us per minute. So that's for 1 minute. So 528 times 1 obviously is going to give us 528. That means we are going 528 feet per minute when we're driving 6 miles per hour. We're not done with this, okay? That is not the answer. Some people may stop right there. We want to know what the area that we're taking up. So in terms of area, we're not dealing with a linear foot. These things, that 528 is a linear foot. So that's how much we're going forward. We want to know how much ground we're covering, okay? And so we have to take that 528 and we have to multiply that by the 24 feet. Now, because both of these things are in feet, okay, we don't have to do any conversions. So we can simply take our 528, we can multiply that by our 24 feet. And this thing is going to give us 12,672. Okay. And that 12,672. This right here, this 12,672, that is what we would consider square feet. And we represent it with, right, just SQFT. So that's how many square feet that spray rig would be covering in 1 minute. Okay, we're covering 12,672 square feet in 1 minute. Now, to kind of put this in perspective a little bit, this is going beyond what this question is actually asking. Okay, does anybody know off the top of their head how many square feet are in 1 acre?
5,940.
5,940. That's closer to more of what a mile would be. A mile is 5,280 feet, linear feet, right? But an acre, we talked about this last week. Somebody's chatting it up here. Let me see. Where's my chat at? 5,000, or sorry, why did I say 5,000? 43,560. Thank you, Jared. Okay, 43,560. If you are in agriculture, that should be a number that you should remember. If you don't know that, you should get that in your head. I used to get that into my students' heads when I was teaching, high school, because we would use that number for all sorts of different equations. For my ag mechanics team to my vine pruning team, that number was used. Understanding how many square feet in an acre is kind of an important thing. So if you don't know that, get that in your head. Understand there are 560 square feet in an acre. And that's just kind of a standard number. You don't have to remember. You can find that information out pretty easily. But if you're in agriculture and you're doing this stuff, you should know that. Now, again, we're taking this thing above and beyond because we're just kind of curious a little bit, or at least I am. If I have 43,500 square feet in 1 acre, and in 1 minute, I am covering with this spray rig 12,672 square feet, okay, I could simply take that 43,560, divide that by 12,672, and that's going to give me 3.43. So what that means is that to cover 1 acre with this spray rig at the speed and the length that boom is, it's going to take me 3.4375 minutes, right? Or 3.4 minutes, 3.44, I don't care, right? To cover 1 acre of land. Now you may think an acre of land is pretty big, and if you have a house and you're on an acre of land, that's pretty good, right? In farming, an acre of land is pretty minuscule, right? It's a lot of work to set up a spray rig. If we were spraying 1 acre, it wouldn't take us very much to get that 1 acre done, especially if it's like an open field and you can just drive across and you have a 24 foot boom on the back end of it. You're going to cover a lot of acreage really, really quickly. Okay. So in 3.4 minutes, you're going to be covering 1 acre of land. Okay. And we do that using how many square feet are in an acre. Cool. I know that's more information than what you guys wanted to know, but I think it's kind of neat to understand that and to do that. We are going to get into at the end of the semester. I'm not going to throw this out right now because I don't want to bombard you with a ton of math. But at the end of the semester, we're going to go through and do calculations on field efficiencies, wheel slippage. We talk about it like machinery management. So, how long should it take us to get done with a field? Those are all things that, if you're, a manager, and you send somebody out to do something, it's important information for you to get out there. So that way people know, hey, if I got some person that's on a tractor and they're operating, how long should it take them to finish that field, going the speed that they're going? Okay. Or if you're, doing custom harvesting and stuff for people, how long should it take me to get done with that field? So that way I know what to charge. Because if you're paying somebody to run the tractor, you're paying for fuel consumption and all that kind of stuff, to be able to calculate what your cost should be, you've got to know all that information there. So really what we're covering in 1 minute is 12,672. We use those numbers to really determine how long it should take us to get done with a field. I could take that and say, hey, we had a 10 acre field and we could go beyond that and we could determine how long it would take us to. But we're going to do that again at the later part of the semester. Not really worried about that right now. Questions with that one?
I have a question.
Yes, ma'am.
So for the distance covered equation, we're supposed to divide by minutes, right?
Yes, divide by minutes.
Then why did we multiply 528 by 24?
Oh, so on this, this equation that we did here, okay,
Yeah.
that, I'm going to type it out on here so that way you can see it. So we did 6 miles per hour. 6 miles per hour. We times that by, where's my 88, right? Where's my equation? Yeah, 88. That 88 is a constant, right? The 6 mile per hour is going to change, right? We divide this by the minutes. In this case, it's 1 minute. Okay. And then we equaled, what was that? 525? Was that the answer?
528.
528. Okay. That is the completion of that equation. Okay. Of this equation. But what we need to do is we need to talk about the area covered. And when we talk about area, we're talking about the square area. Okay. So if you think about like a box, right? If we had a box, I don't think I can. Let me see if I can draw here. So essentially we're driving in a straight line, right? And you imagine this as a box. Let's assume this section right here is our 24-foot boom length. And this length right here, okay, this long length right here, that is how the distance that we drove. So that is our 528 feet that we drove. This is the 24-foot width. So simple like algebraic equation, A times B will give you the area of the that we sprayed.
Okay.
Does that make sense? Yeah.
Yeah,
That's good. That's a good question. That's a really good question because it helps kind of put that in perspective. Normally, what we would do in here is we would actually, kind of doing some of these things, we would actually just go through and I would have you guys drive something and we would spray water out on a road. We would measure the road and we would do that and we would get more of that visual. But it's a little bit harder to kind of do that, here. And just wouldn't pick up very well, I don't think, like in a video to kind of do that. But understand that we're dealing with, a square area that we're taking up. So it's the distance that we're driving and the width of the boom that we're kind of dealing with. And so that 12,672, I don't have that equation in here, right? But it's just, length times width, gives you your square feet.
Okay, thank you. Yeah, that helps.
Good. All right. Number 6, what mile per hour would be needed to spray 28 gallons per acre with 19 nozzles spaced at 20 inches apart, and each nozzle was putting out 13 ounces in 15 seconds. So this one is kind of like the GPM equations that we have here. It's kind of like the GPA equations that we have here, except we've added another one in here, and that is your miles per hour. Now, each one of these equations is really the same from one to another. They're really not different. It's just how we write them, you know, and how they appear might appear differently. Yeah, that should be right. But all of these equations, when we deal with like algebra, because that's really what this is just, you know, basic algebra. You can take, if you have all these known variables, you can take those things and plug that in and find an unknown variable. In this equation right here, our unknown is our miles per hour, right? What miles per hour should we be driving? And so what we're going to do, I have this equation. This equation is not on your sheet. And I don't know why, because I feel like if you're like an operator, right, or you're managing people that are operating, not necessarily on the PCA side of things, but if you're actually the one in the field or helping people that are in the field to operate, there's really kind of two things that you need to know. You need to know what your GPM output should be, and we can adjust our GPM by adjusting our nozzles, by adjusting our pressure, but you can also adjust how much gallons per acre you're applying by adjusting your speed up and down, right? Because all these numbers are going to affect one and the other. The faster we go, okay, the less material is going to drop down on that field, okay? Or if we have a high output on our nozzles, okay, you can slow it, you can speed it up, or if you have a low output, you can slow it down, and you're going to change your application rate or your GPA. Now, most of the time when you are dealing with requisitions from like PCAs, they're going to give you the required gallons per acre that you need to apply. Okay. So you're really not going to, not that you don't deal with the GPA equation, but you do, but a lot of times you're not really looking for that. You're going to get a requisition. It's going to say, you're going to have all these chemicals and you need to apply, 25 gallons per acre. You need to apply 40 gallons per acre, right? And then you have to get your nozzles and your speed to set up to do that. Now, sometimes we could take an arbitrary speed and we could say, hey, I'm going to go 4 miles per hour. I'm going to go 4.5 miles per hour. And that's what we do a lot of times, okay? Because speeds aren't going to change a whole lot. And then we can use that to determine what nozzles we have. Or if you have nozzles, let's say you don't have any additional nozzles and you need to make an application rate that's higher, right? And you know what your output is, you know what your GPA is, but you want to know, okay, let me just adjust my tractor speed to adjust or to account for that. Okay. These equations are going to work for you with that situation. Just like those ones, we have the 495s, we have the 5,940s. Those ones are the constants. It depends on what we have. And just like those other ones, okay, keep it simple. Try to not convert, try to not do as much math as possible. Very, very simple. Each one of these equations will get you there. Just one's going to be easier than the other. So in this case, again, I always kind of default to this 5,940 just because it typically tends to not have as much equations built into it. So I think that's probably the one. I'm going to scroll this thing down a little bit here. I think that's probably the one that we're going to kind of be dealing with is that one. Oop, that one right there. So we're going to take and we're going to plug our numbers in. We need to first figure out what our GPM is. This is for one nozzle. This is not the total one. If we're using this equation down here, the GPM up here would be total. So it's going to be all of your nozzles combined together. Okay. Again, it's just, it's more steps that you have to do. I feel like it's easier to just do it for one nozzle. So we know that our nozzle is collecting 13 ounces in 15 seconds, just like before, times that by 4. That's 52 ounces per minute. We have to divide that by the 128. How many ounces are in a gallon? And that's going to give us 0.40625. We can take all of those numbers. We can multiply that by our constant, 5,940. We're going to get a real big number, right? 2,000. I'm not going to read that. You guys got that. The nice thing with this equation, I don't have to do anything, right? That's the stuff that's in parentheses is now complete. I want to divide that by my GPA. In this case, my GPA is 28. And I get 86. Okay. And all we got to do is divide that by our width, which is 20 in this case. And we get our number of 4.3, we're going to say 31 miles per hour. So that's how fast we would need to set our tractor up when we're driving through that field if we have that output on our nozzles and if our required GPA was this right here. So you can kind of fine tune your tractor and how fast that's running as opposed to just fine tuning your nozzles. Okay. In some cases, it may be easier, right? Depending on different applications, I may not want to change out all the nozzles on my spray rig. I may just want to adjust my speed a little bit to basically get that same output. Okay. Instead of having to change the nozzles if I have a more or less output. Typically our speeds on spraying, most like kind of broadcast sprayers where we're doing like spraying weeds, herbicides, things like that. You're going to be somewhere within the 4 to 6 mile per hour range. You may be on the higher threes. Some spray applications, we go a half a mile per hour. And I think I talked to you guys a lot last week when we're doing some sprays in orchards, sometimes on oranges. I can't think of the chemical right now, but I think it's a pesticide that we spray on it, or maybe it's a fungicide that we spray on it. And they go really slow and they apply like 500 gallons to the acre. It's crazy how much material you put out. And do that. It takes a long time, obviously, because you got to fill up tanks and do all that kind of stuff. But in this case, right, we want to run 4.31 miles per hour. When I go and I give you a quiz on these things, it's going to be a numeric equation. Now, in this case, if you were like, hey, you know what, I see 4.30 and you just put 4.3 as an answer, there is a range that's within that is going to be acceptable. I am not going to expect you to write down this whole number. If you go, and I typically will do, like on this example, I would probably say 4.30 to 4.32. That's going to be the numbers that are right. If you get anywhere in between that range, if you write this whole number down, that would be within that range, you're going to get it correct. Okay. So you don't have to worry about writing it, and getting that 4.31. If you forget to kind of round it, up or down, you're going to have that variance built in. So that way you're not stressing over it too much. If you plug the numbers in right, and the number looks right, if you got a number that was like, 50 on the miles per hour, probably something wrong. Maybe you skipped a step. Maybe you put the number in wrong. Just start fresh with it. Redo that equation to make sure that, you have it correct. Cool. What questions do we have? All right, we'll go on to number 7. How many gallons per minute per nozzle would need to be applied, and how many GPM would the pump have to put out to supply the needs of the sprayer with the following parameters? So you have a nozzle spacing that's 20 inches, 19 nozzles. You recommend 20 gallons per acre. The spray rig is traveling at 4.5. Which equation are we going to be using here? Or which 2 equations? We can narrow it down to that. GPM, GPA, miles per hour. Which one? What are we trying to get out of this? How many gallons per minute per nozzle would need to be applied, and how many GPM would the pump have to put out to supply the needs of the sprayer with the following? The top 2. Okay, and which one we're going to use, right? Depends. Again, I like to default to just this 5,940 because it tends to just be a little bit easier. We'll run through these things again. We know what our miles per hour is, right? Gosh dang it. Close that down. We know what our miles per hour is. Oh my gosh, what am I doing? What am I doing in my life? We're running 4.5 miles per hour. Okay. We have not a swath width. We have a width of 20 inches on the nozzle spacing. We have a gallons per acre of 20. I'm going to take that number, divide it by 5,940. And that means that my output should be 0.30 gallons per minute. Now there's 2 parts to this question. Okay. And it's also asking us how much gallons per minute would the pump have to output. So we're trying to match a pump with the needs. You could have a nozzle that has 100 nozzles on there. Okay. And it could be using 1 gallon per each nozzle. And if you only have a 50-gallon pump, okay, that's not going to be able to supply enough material to be able to pump those things out. So the pump has to be able to match what the output rating is, okay? How do we figure out what the output is? Well, if we take that 0.3 GPM, type it right here. If we have that 303030, right? Carry on. We multiply that by the number of nozzles that we have. In this case, it's 19, okay? And our number right there, our 5.75, we'll just go 76 to round it up. That's how many gallons of output for a pump, right? That's the pump should be outputting. If I had a 5-gallon pump, right? So I had a pump, right, that output 5 gallons per minute, okay? Would that pump work and suffice for the spray rig at its current settings? That's a yes or no. If I had a 5-gallon per minute pump, so it's outputting 5 gallons per minute, would that pump work for the settings that we have on this spray rig? Michaela's saying no, right? It's under the gallons that we would need to supply. Your spray is probably not going to be uniform if that happens, in which case we probably would need to adjust some things down. Maybe we go with a smaller nozzle, so that way we don't need as much output. And then we slow down our speed a little bit. So that way we can get the same application rate, but not overdo our pump. Typically, you're not going to buy a bigger pump, right? That's a little bit more time consuming. We're going to do some other things that are a little bit cheaper. If that continues to happen and you continually have a pump that is underpowered, then you probably need to get a new pump, maybe get a new spray rig, because it's not meant to handle what you are trying to accomplish. In this case, very simply, you could have a 6-gallon output GPM pump, and that would suffice for this. Most of the time, you're probably going to have a lot more. It doesn't matter if you have a 10 or a 15 gallon in this example. Remember, some of that material is going to be rotating back into the tank for agitation. So if you have more gallons than what is needed, that's okay, because the rest of that stuff is going to get cycled back through, and you kind of almost want that. You don't want to have your gallons to match up exactly, because that's one way that we do, create agitation in these tanks to keep the chemicals suspended. So I kind of put these things in the wrong spot, but that's okay. GPM per nozzle, GPM for sprayer. The GPM for sprayer, right, that total number, that's kind of important to make sure you can match your equipment with it. Questions with that? We've kind of done that one. We just kind of added that last little bit of multiplying it to kind of figure out those gallons there and why it's important to know that. Number 8, what is the speed of the tractor that is traveling 1,500 feet in 4.2 minutes? This one should be a pretty simple one. We have an equation on the left-hand side that deals with that, and that is our miles per hour distance. So what we want to do is, if we want to know what our speed is and we know what the distance that we are traveling is, okay, we can figure these things out, and we know how long we're traveling. That's kind of another important factor. So on here, we'll take our equation, our calculator. All right. And what we're going to do is we're going to plug these numbers in. Now, our feet is 1,500 feet. It's got to be in feet. If it's in inches, you have to convert that from inches into feet. Okay. The time has to be in seconds. Okay. So the time has to be in seconds. This example, it's 4.2 minutes. So again, to kind of make this a little bit easier for, kind of the calculators and punching them in, I'm going to do this bottom portion first. Okay. And what I'm going to do is I'm going to take my minutes, which in this case is 4.2, and I'm going to convert that to seconds. And can somebody help me out? How do we convert minutes into seconds? I do know this, by the way. I'm just asking this, keep you guys engaged. Don't think that I'm dumb and I don't know how to do this. What do we need to do to convert minutes into seconds?
You multiply or divide by 60.
Multiply or divide. That's two options. Which one do you think?
I think multiply.
Multiply. Yeah. So if you have minutes and you're trying to convert it into seconds, understand, and this is kind of a way you can kind of think about it. You want a bigger number in seconds than there are in minutes, right? So if I have 1 minute, how many seconds do I have in that minute?
60.
60, right? That's a standard. That doesn't change at all. Okay. So 1 minute, right? One is a lot smaller than 60 because there are 60 seconds. So to get this number to be bigger, you're going to multiply it. Now that can work inversely, right? Because if you have seconds and you want to convert it to minutes, you would divide the seconds to convert it to minutes. But like I said, this is really where people mess up, is the conversions. They might take this equation right here, the mile per hour distance. They might plug in the distance. They might plug in the time, put 4.2 minutes. They're not realizing it's in seconds, and it throws their numbers all off, and it's just completely wrong, right? You're going to get a number that's really weird if you do that. Maybe, I think, really small if you do that way. So 4.2, we're going to times this by 60. That's going to give us 252 seconds. Okay, that's how many seconds we're driving the tractor for. You're going to times that by the 88. That's the constant, right? How many feet per minute that we are driving if we're going 1 mile per hour. And we're going to get 22,176. 22,176. Okay, that's the bottom number. We want to deal with the top number now. So we're going to clear this thing out. We want to take our distance. This is 1,500 feet. It is in feet. That is what we have in the equation. We're good there. No conversions needed. We're going to multiply that by 60. 60 is just a constant in these things. Okay. Again, if we want to know why it is, then I can tell you. In this case, we get 90,000. You take that 90,000, you complete this equation by dividing it by 22,176. And then our speed is going to equal 4.05, 4.06. Okay. That means that tractor is driving I typed that in wrong. 4.06 miles per hour. Okay. That's how fast that tractor is going to be traveling. Cool. You're going to see this equation. The numbers are going to change a little bit, but the equation doesn't. Okay. Just make sure you got the conversions correct. Last one. You're spraying tomatoes at 40 gallons per acre. This one is not going to be dealing with one of these questions here, but this is definitely something for mixing that we would do. You're spraying tomatoes at 40 gallons per acre. You have 100 acres to spray, and the material you are using is recommended to apply 1.2 pints per acre. Your sprayer has a 200-gallon tank. How many times will you need to refill your tank? And how much material will you need to add per fill? So this tank, right? Let's do this first part. How many times will you need to refill your tank to complete this field? There's a couple things that are important. One, you know that you have a 200-gallon tank, yes? Let me pull up my calculator here. So you have a 200-gallon tank, okay? You are applying 40 gallons per acre. So how many acres does one tank do? What math do we need to do, and how do we figure that out? $200-gallon tank, you're spraying 40 gallons per acre.
Divide by 40.
Divide by 40. So that means that each tank is going to do 5 acres, right? Each tank is doing 5 acres, okay? Now, second part of that, well, it's really still the first part. How many times are you going to need to refill this tank to complete this 100-acre field? You're going to take the 100 acres, divide that by how many acres you can do in one tank, and you're going to get the answer, 20 refills on tank. So you're going to have to go back through this field, and you're going to have to fill that spray rig up to complete that 100 acres. You're going to have to do that 20 times. Now, in each of the loads, the chemical that you're applying, okay, and this is really irrelevant, doesn't matter what chemical it is, you're going to be putting 1.2 pints per acre on this field here. So in a tank, right, we're doing 5 acres per tank, right? 5 acres per tank. And for every acre, we want to apply 1.2 pints of our chemical. So what you're going to do is take the 1.2 pints, times that by how many acres the tank can do. And that's going to give you 6 pints. Now, sometimes with this, with these equations, you may have something that's like multiple pieces, like multiple chemicals that you're putting in at once. It's not necessarily just a straight one chemical. In some cases, you're going to have to apply multiple chemicals, and you have to do these things for each chemical. But once you know how many acres one tank will do, you can figure out how many chemicals you need to mix in to get that application rate correctly. That application rate is your water and your chemicals all mixed together. Okay. The concentration and how much you're actually putting in those things. Okay. Your PCA is going to tell you what that should be. And typically they're going to tell you, you want to apply this chemical, you want to apply 1.2 acres or pints per acre, 1.2 gallons per acre. Why don't we just take, let's say, for instance, Roundup and spray Roundup directly onto the field? Well, you wouldn't be able to apply that at the rate that you needed because the stuff is concentrated, right? So we dilute this with water so that way we can, spread that out a little bit more easily. Theoretically, you would need to, if you had the ability to kind of spray this thing out and then target everything and get the right application rate. But we're cutting this stuff with water to kind of mix that in and dilute those concentrates that we're dealing with to make it easier for us to spray. So in this case, we want 6 pints. We could convert this into gallons if we wanted. Does anybody know how many gallons 6 pints would be? And how would we figure that out?
I have a question.
Yes, ma'am.
So that's 6 pints per what again?
That's 6 pints per, I should say that. Yeah, I should ask that. 6 pints per load. Okay. So every time we load this thing up, every time we load our tank up, we would be applying 6 pints of the chemical in addition to the 200 gallons of water. Okay.
Okay, thank you.
Yeah. So, and we could convert that, right? You guys know how many pints are in a gallon? Maybe let's start with this. How many quarts are in a gallon?
4.
4. Okay. And a pint is half of a quart. So how many pints are in a gallon?
8.
8, right? So this one, if you did, what would it be? I think it's 8 divided by 6. No, 6 divided by 8. That's more like it. So you could say 6 pints, or for this field, I would be applying 0.75 gallons per load. If I knew how many loads I had, right? I know I'm doing 20 real fills on this tank. If I'm working at 0.75 gallons per load, I could take that number, 0.75. I could times that by my 20 loads. And in total, I'm going to need 15 gallons of material for the whole field. Does that make sense? So like if I'm a PCA and I'm kind of like doing these things, I'm like, okay, we need to put the stuff on this field. We've got, this whatever, I don't know, pesticide or herbicide, right? Insecticide, fungicide, I don't care what it is, right? If you're like, okay, we need to apply this to that field, okay, we can multiply these things and say, okay, they're going to need 15 gallons of material to complete this field. You may give them a little bit more because sometimes things happen. Sometimes, the speed of the tractor is not right. And maybe you don't, get to complete that field. And so we may, throw in another gallon. So that way we have enough material. But you would need, at least in a perfect world, you would need 15 gallons to complete this field, right? If they gave you 10, you would not have enough to complete it. You would have to wait to be able to make that application there. And you definitely wouldn't want to stretch that out and dilute that anymore, because the more you dilute it, the less effective that chemical is going to be. And some things, it's really critical that if we don't apply the right amount and if you apply too little, it's almost as if you didn't apply anything at all. So it's not like it's some things don't act like a percentage wise. Sometimes it just won't have an effect. Okay, so chemical stuff, they're expensive. You want to make sure we get it right. Does that last one make sense? There's not an equation with it, but a lot of it's just kind of a little bit of logic there. and kind of thinking a little bit about it. Using your algebra. Any questions with this one or any of the other ones? All right,
I'm good.
good.
Oh, no, I said I'm good.
Oh, you're good. Okay. So if you guys don't have anything else, just make sure you get that the midterm done for those that haven't done it. And then look for that quiz later on in the week. I'll post that thing up. I try not to kind of combine those things too. So I might post it, Wednesday or Thursday. And then if you got some time, kind of run through that and do that quiz there. It's going to be something very similar to what we did today. If you don't have anything else, I'm going to stop this recording. And
Thank you.
you guys are free to go.